Hello everyone, welcome to this lecture series on thermodynamics. Today we will learn about heat engine and the efficiency in this series. So first let's understand what is a heat engine. So heat engine generally transforms the thermal energy or heat into mechanical energy or work. Of course, they cannot do this task perfectly. Some of the heat engine is not converted into work, but it is dissipated as waste heat energy into the environment. So the quantity of heat which is absorbed by the engine is not completely converted into work. Some of the energy is being dissipated as waste heat energy. Hence, for every engine, there will be a limit for its efficiency. That is, no engine is 100% efficient as some of the energy is being wasted. So in thermodynamics and engineering, we can say a heat engine is a system that converts heat or thermal energy into mechanical energy, which can be then used to do mechanical work. Some of the examples of heat engines are gasoline and diesel engines, jet engines, and steam turbines which generate electricity can be taken as an examples of heat engine. Now let's see the types of heat engines. There are two types of heat engines: external combustion engine and internal combustion engine. In the case of external combustion engines, the fuel burns outside, external, and away from the main engine where force and motion are produced. The best example for external combustion engine is the steam engine. Then comes the internal combustion engine. Here, the fuel burns inside the cylinder, internal. Hence, an example for internal combustion engine is the car engine. Among these two types of combustion engines, external and internal combustion engine, this internal combustion engine is more efficient than the external combustion engine because there is no energy wasted during heat transfer between the boiler and the cylinder. So these are the two types of heat engines. Now we will see what are the main parts of the heat engine under the construction. We know that a heat engine converts the heat energy into mechanical work. The main parts of the heat engine are the source, the working substance, and the sink. The source is also known as the hot body. It is always maintained at constant high temperature T1. The thermal capacity of source is very, very high. That means even if any amount of heat is withdrawn from it or given to it, then it does not affect its temperature. The temperature is always maintained at constant high temperature T1. So this is regarding the source. Then comes the working substance. Working substance, generally ideal gas is taken as the working substance. This working substance has the capacity to absorb the heat energy from the source or reject or give away the heat energy to the sink. So this is regarding the working substance. Next comes the sink. Sink is also a reservoir of heat. It is also known as cold body. It is always maintained at a constant low temperature T2. Its thermal capacity is also very high, like that of source. Hence, if any amount of heat is withdrawn from it or given to it, then it does not affect its temperature. It is always maintained at constant low temperature T2. So these three are the main parts of a heat engine: source, working substance, and the sink. Now let's see the working of heat engine and the efficiency of the heat engine. So here is source, working substance, and the sink. So this working substance absorbs the quantity of heat Q1 from the source, does a work W, and rejects a quantity of heat Q2 to the sink. So Q1 is being absorbed by the working substance. It is doing a work W, and Q2 is the quantity of heat which is rejected to the sink. So the work then can be written as W is equal to Q1 minus Q2. Now we will see the efficiency. Efficiency of a heat engine is generally denoted by eta. and is defined as the ratio of work done to the quantity of heat absorbed. Q1 is the quantity of heat absorbed and W is the amount of work done. So eta, efficiency eta is equal to W by Q1. We know that W is equal to Q1 minus Q2. Substituting this in the above equation, we have the efficiency as eta is equal to Q1 minus Q2 by Q1, or eta is equal to 1 minus Q2 by Q1. So this is the expression for the efficiency of heat engine. Eta is equal to 1 minus Q2 by Q1. Now here, if Q2 is equal to 0, what is Q2? Q2 is the quantity of heat rejected to the sink. That means if all the amount of heat absorbed is being converted into work, and if there is no quantity of heat being rejected to the sink, then what happens? The efficiency will be 100%. So for an engine to be 100% efficient, Q2 should be 0. Actual practice, this is not possible because there will be some loss of energy in the system. Hence, for every engine, there is limit for its efficiency. In order to improve the efficiency, or in order to make it nearly 100%, we can go for an engine where the efficiency is maximum. This is only for Carnot's ideal heat engine. So this is the expression for efficiency. So I hope you understood a heat engine, the main parts of heat engine, its working and efficiency through this video.